Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the third lecture on polymers. In this video, we will be discussing about condensation polymerization. Condensation polymerization is also known as step growth polymerization. So let's get started. So two basic things which we have to remember while studying condensation polymerization are as follows. First is the requirement of two bifunctional or trifunctional monomeric units. That is, the monomers should contain two or three functional groups in their structure. This is the first condition. Second is these condensation reactions, they result in the loss of some simple molecules, example water, alcohol, hydrogen chloride, and lead to the formation of high molecular mass condensation polymers. These are the two important things about condensation polymers. Now, what is the next question is why the condensation polymerization is also known as step growth polymerization. Why? Because the product of each step is again a bifunctional species, and the sequence of condensation goes on. Since each step produces a distinct functionalized species and is independent of each other, this process is also called as step growth polymerization. I hope it makes sense, right? Let's see through an example. Terylene or dacron. So here the monomers are ethylene glycol, that is the common name of ethane 1, 2 diol, and terephthalic acid, benzene 1, 4 dicarboxylic acid. In ethylene glycol, two functional groups are present, OH, OH, hydroxyl groups. And in terephthalic acid, COOH groups are present. So what happens is when these two monomers react together under some conditions of temperature and pressure, this alcohol molecule removes one hydrogen and acid molecule removes hydroxyl group, OH group. And when this H and this OH combines, it results in the formation of water molecule and leads to the formation of terylene or dacron. So from here we can start. This H is going, so there is a free valency of joining. Next CH2, CH2, H is again going here, C double bond O, and this benzene, and again here OH is going, so this is OH, right? This is the formation of terylene or dacron. So what are the uses of terylene or dacron that we have to study? First is very important is that it is used in making plastic bottles, sheets, ropes, nets, and sails. It is also used to make hardware, clothes like dresses, raincoat, fleece, and jackets, and dress material. A very important property of terylene is that this fiber is crease resistant. This is a very important thing. Crease resistant. This is all about terylene. Now next we will study about some important condensation polymerization. First is the polyamides. So what is a polyamide? The compounds which contain C double bond O N H. This functional group, they are called amides. They are examples of synthetic fibers and are termed as nylons. Polyamides are examples of synthetic fibers and are termed as nylons. So what we need for the method of their preparation is diamines with dicarboxylic acids or condensation of amino acids or their lactams. These are the prerequisites for the formation of polyamides. Now, polyamides, as we can see, is also known as nylon. We have to study two types of nylon under this heading. First is the nylon 6 and second is the nylon 66. So, nylon 6, why the name is like that? Because in nylon 6, the monomer caprolactam, it has 6 carbon atoms. Like start from here 1, 2, 3, 4, 5, 6. 6 carbon atoms, and it reacts with water molecule and leads to the breakage of this bond and leads to the formation of nylon 6. And nylon 6 is used for the manufacture of tire cords, fiber fabrics, and ropes. This is nylon 6. Next, we have to study about the nylon 66. So, why the name is nylon 66? Because the two monomers, monomer 1 plus monomer 2, both have 6 carbon each. That is why its name is nylon 66. Example we will see next. What are the constituents of nylon 66? So first is this is adipic acid. 6 carbon atoms are present in this adipic acid. And this is hexamethylene diamine. This is hexamethylene diamine. Under pressure of and high pressure and 553 Kelvin, what happens is adipic acid, it loses its OH molecule, this OH, and the hexamethylene diamine, it removes one hydrogen atom. That is one hydrogen from here and OH from here. They both react to form the water molecule and it is removed and it leads to the formation of nylon 66. This is the condensation reaction. Now we have to study some examples of nylon 66. Nylon 66 is a fiber forming solid. It is having high tensile strength. The characteristic can be attributed to the strong intermolecular forces like hydrogen bonding. This is very important. These strong forces lead to the close packing of chains and thus impart crystalline structure. What is the use of nylon 66? Nylon 66 is used in making sheets, bristles, for brushes, and in textile industry. This is about polyamides. Next, we have to study about the polyesters. So first, we should know what is an ester. R C double one O R dash. This is an ester. This linkage C double one O. This is an carboxylic linkage. So what are polyesters? These are the polycondensation product of dicarboxylic acids and diols. Terylene or dacron is the best known example. The what we have to remember is the catalyst of the terylene or dacron preparation reaction. Zinc acetate, antimony trioxide. Zinc acetate, antimony trioxide catalyst. And temperature is 422, 460 Kelvin. Let's see within next slide. So this is the ethylene glycol, this is terephthalic acid, this is terylene glycol minus water. Dacron is crease resistant and is used in blending with cotton and wool fibers, and it is also a glass reinforcing material used in safety helmets. This is about terylene or dacron. Now next we have to study about the phenol formaldehyde polymer, bakelite, and related polymers. So first we should know what is phenol. Phenol is a simple molecule, benzene, with the hydroxyl group. This is phenol. Formaldehyde, we all know, H, C double bond O, H. This is formaldehyde. So phenol formaldehyde polymers, they are the oldest synthetic polymers. So how the reaction take place is, they are obtained by the condensation reaction of phenol with formaldehyde in the presence of either an acid or a base catalyst. So the second reaction condition. Now what happens during the reaction is, the reaction starts with the initial formation of ortho and or para-hydroxymethyl phenol derivatives, which further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product could be a linear product novolac used in paints. Let's see through a slide what happens. So first thing is, when this phenol reacts with formaldehyde, this is formaldehyde, you can write it as HC double bond O. When this phenol reacts with formaldehyde in presence of acid or base as a catalyst, it forms ortho or para, ortho and para hydroxymethyl phenol. So these are formed ortho, ortho para, ortho, ortho, ortho para. So when these ortho, this ortho, here this is a hydrogen. When this react with another molecule of ortho from here, this H and this H is removed and it is forming a methylene group. So this linear structure is known as novolac. When this novolac undergoes cross-linking with the another molecule of novolac, it leads to the formation of bakelite. Right? So what is the use of novolac? So novolac is basically used in paints and it is heated with formaldehyde to undergo cross-linking to form an infusible solid mass called bakelite. And bakelite is formed by cross-linking of linear chains of the polymer novolac. Where the bakelite is used? It is used for making combs, phonograph records, electrical switches, and handles of various utensils. So novolac cross-linking is shown in this slide. So here this is CH2 group, this is the methylene group, this CH2 and this particular position here there is a cross-linking by CH2 group. This structure is known as bakelite, right? Next we have to study about the melamine formaldehyde. So first we have to study what is melamine. Melamine is a compound like this. Suppose how to remember this is like make a benzene. At alternate position put nitrogens, put double bonds, and the carbon atoms where there is free space there you put NH2 groups. NH2 NH2 groups. This is about the melamine. Our melamine reacts with formaldehyde. It forms a resin first. So how the resin is formed is, this one hydrogen is removed from here and it is formed NHCH2OH. This is the one thing. It undergoes polymerization to form melamine polymer. All the vacancies will become free. This hydrogen will go. Here also hydrogen will go. This CH2, this OH will go. So this is free valency and this is the N is the number of moles. So this is a melamine formaldehyde. This is used in the manufacture of unbreakable crockery. So this is about melamine formaldehyde polymer. So if you like the video, hit the like button, share with your friends and subscribe to the channel, and don't forget to hit the notification bell for upcoming videos. Thank you and have a nice day.